Good afternoon, everybody. Welcome to the Biomedical Informatics Seminar. Today, as you know, is a very special seminar because it's when we present the Morgan Award. And this year's recipient is Duy Bui. And as you know, it's a yearly competition that we have. People submit their papers and they're judged by a committee. The committee is led by Scott Evans and Chris Maloney. And they review the papers and they select the best paper, and Duy's paper was selected this year. And so we're very pleased to have him receive this award. And so first of all, let me tell you a little bit about, Duy joined our program in the fall of 2011. He's working with Guilherme Del Fiol as his advisor, and he's going to tell us all about his research today. And I think we'll start by giving him the award. And then we have some family representatives from the Morgan family, and they're going to come up and talk a bit about their dad. Do we have someone taking a picture?
So my name is Rick Pike from the Intermountain Research and Medical Foundation, and on behalf of the foundation and Intermountain Healthcare, we want to present you with this award, which is very nice. I wish I could say I designed it. And more importantly, a $5,000 check that comes with it.
Thank you very much.
I ought to just say, and I don't want to steal any thunder from the Morgans, but as I read Duy's paper, and believe me, I understood very little of it. Look at me, right? But what I understand of Dr. Morgan, given his impact in the world of informatics and what he did in coding that is still used today, I think he would love to know that this award is going to a young man who's just the paper he's going to talk about today, the research he's doing that could help improve and speed the production of clinical procedural guidelines, which have become so important in healthcare today. So anyway, that's my inch-deep understanding, but I was impressed in thinking about that and thinking about your father and how pleased he'd be. So again, congratulations, and we're thrilled to be a part of this.
Thank you.
Just use this microphone. Yeah. Well, actually, it's being recorded.
Oh.
And so you do need to talk into the microphone.
No.
I know. There you go.
I'm not very good at that. So I just want to tell you a story about my dad. I'm not going to tell you anything about his professional life, and maybe the story will just maybe illustrate a little bit what he was like. So my dad was an enthusiastic hiker, and he hiked in places all over the world. If he'd get a chance, he'd go on a hike somewhere. And one day, he and I were hiking near the Utah-Wyoming border, east of here. And it was a nice afternoon, beautiful weather, and we were hiking through sort of like a grassland area, up and down these hills. And he said he always had a map. He was also a map enthusiast. So he had this topographical map that he pulled out of his pack, and like the paper map, right? And he said, "Oh, we were about 2 hours from our car, which was in the middle of nowhere." And he said, "I can see on the map that if we take this train tunnel, we can save ourselves about an hour back." Yeah, what could go wrong, right? So you know where this is going, right? So I'm like, yeah, let's do it. So we go down to this train tunnel. We can see it's a used train. It's a used track, and we start walking through the tunnel, and it's dark. It's probably a quarter mile long, actually. And he always had a walking stick. Usually had a walking stick, or sometimes poles, but usually a walking stick, and the kind that you could put a camera on the top, So we're walking through the tunnel, and you start to hear this little sound, like a little singing sound. You know how the rails make that sound, and we're like, oh no, just what we thought. It's a pretty narrow tunnel, so we kind of started to run a little bit and try to go faster. And he's tapping against the side of the wall. We can't see it, but he's using a stick to hit against the side of the wall. And the train's getting closer. And luckily, right, that there's little cutouts in those tunnels for the service guys if something happens. So luckily, we find one, and we both back up in this little cutout. And the train's getting close. And when it goes by, it was it was just like so loud, and the wind just like rushing by. But we're huddled against the thing, and I can feel spiders on me. It was like, yeah. But so then the train goes by, and it's pitch dark because of the exhaust that's in there, and the diesel exhaust. You couldn't see either end, so we just waited a few minutes, and the exhaust was really choking. And then we said, okay, there we go. We started to go, another train came. So in that quarter mile, 2 trains came. It took us, like, I don't know, 20 minutes or whatever to finally make it through. But maybe what that illustrates is my dad was always up for an adventure and willing to take a risk. So that's what I have to say.
Okay, to start with, I feel very exciting and honored to receive the John Morgan Award this year. I feel that I could never apply for this award, I think 3 weeks ago. When I sent an email to Guilherme and say, do you have any chance to apply for this award? And he said, you have very good chance. So I feel more confident that I apply for this. So introduce a little bit about my background. I have the background in computer science and engineering before joining BMI at a PhD. So I grew up in a healthcare family. So my fathers, my mothers, my younger brother are all physicians, and only me chose a different path. The reason is I feel so excited about the computers when I was so young. So I decided to become a software engineer or a computer scientist. So this talk will tell you how a software engineer will end up with a biomedical informatics scientist. And I would summarize some of those software that I developed through the tracks. And I don't go into very technical level detail. Some of those will be reserved for my defense next week. I just try to convey the general idea, so why we need those software, how we evaluate those softwares. So first of all, I would like to say thanks to Dr. John Morgan and his families to create this annual awards. To be honest, I feel very humble and motivating for every time a John Morgan recipient come in and talk about their research. I'm not sure that my talk today will have a similar motivating effect, but I will try best as I can. The second, I would like to thank my thesis committee. Special thanks to Dr. Guilherme Defio. He's the key person that keep my thesis track going smoothly. I admire him as a mentor and as well as a great person to be with. Every time I send some email to Guilherme, he always come back with the thoughtful and careful reviews. The second, I would like to thank Dr. Jane Taylor. She is now the faculty at the George Washington University. Majority of my training and publication were conducted by the time working with Jing. I would like to thank Dr. Siddhartha Jona Galada. He is faculty at the Northwestern University, and he provided the funding during my transition periods. Without that period, I could never finish my PhD. I would like to thank Dr. John Hodo. I have been concerning a lot technical and non-technical questions with you. So you always come back with a very good advice. You are a key person to determine my thesis track. Dr. Bruce Bayhill teach my first class in BMI that teach medical language to engineer. So with his class, I feel that an engineer can learn medical language. It would be an initial confidence to decide to switch to BMI. Finally, I would like to thank Dr. Gangler for excellent serve my thesis committee. I would like to thank my family, friend for the social support for every time I need them. BMI had very excellent staff. I always feel that I very supportive. And finally, I want to thank all the collaborators that helped me doing research. To start with, I started my first career as a software engineer in a company back in Vietnam. So the company doing outsourcing business. So although we stay in Vietnam, we still collaborate with the software team around the world to work on their core products. So I worked for the company for 2 years. I worked on several products. So this product is a gateway between the mobile network and the internet. So, and that's one is a software management software that have you monitor and configure the network device on the network. So I'm pretty okay with the software engineer life. They pay me well and I got promoted. The only issue that I don't really like is that there are a million types of software and only few of them that make you really feel exciting. You don't have a chance to work on those products. In a big project, you best can participate in a small component of the software. It's not large enough to make you feel exciting. And the company of the software, when you lead the project, you will be forgotten. And finally, I want to create a software for my own. It's usually a dream of most of the software engineers when they just enter the field when they were young. So I decided to go back to graduate school, start with a master and then a PhD program. So I joined University of Utah in a CS program at the U. This is a joint program between CS department and other departments. So although I study CS class, I working on the chemistry department, and this is how I got funded. This is in my master project, ambitious project. It is funded by $5 million grant by NSF. So the goal is to integrate all the tool and software in the field of computational chemistry into a single workbench and make them talk to each other. So in the old way, the scientist has to do an experiment on computational chemistry. They have to understand the tool, going through a tedious file management process. This way, computer can enjoy doing research like playing a game. They can simply drag and drop and play with the fancy user interface. So their goal is to fasten the scientific discovery through simplify the process of experiment. So I'm booked for this project for 2 years, for my first year as an RA. Although I know nothing about chemistry, so a software engineer, you receive the requirement from your customers. Here is the chemist. But the challenge is you need to understand the system at whole so that what you contribute is meaningful and compatible with the previous work. So by the end of my first year, I have a number of choice, either doing PhD in computer science or PhD in computational chemistry. So by that time, my advisor told me that you should have a look at a BMI program at the U. I go to the website, I talk to some people there. I feel this is something that you really want to do, to making software to advance healthcare. That's something that you really want to do. And my family is strongly supporting me because they are all physicians. So they want me to contribute to medicine, but in a different ways. So by the end of this year, I applied for BMI and I got accepted. So in my first year, I most concentrated on my coursework. I feel the course in BMI is more oriented to research skill rather than industry skill. But they also allow you to take in class from other departments so you can train whatever skill you want. So there's not many plays in Utah for entertainment, but this is very, very close to Vegas and other national parks, and play for skiing and hiking. So you can, I participate some of those trips with my friend. I feel very exciting. The point here is you can either choose, in Utah, you can either choose a busy life like as a scientist, or you can go out to enjoy nature. It's all up to you. So how about research? What I do for the first 2 years? What I do is I work in the project that enhance the patient compliance to distract instruction. Distract instruction is an important material that's given to patients to manage their own health at home. So the problem is the patient only remember half of the instruction given to them, and failure to follow instruction can lead to readmission. And half of Americans don't have inadequate or poor level of health literacy. So how we solve the problem? There are many ways to address this problem. You can generate a very large public health campaign to enhance patient literacy. You can improve the condition in which patient learns the distract instruction. But perhaps the most economist and efficient way is to enhance the quality of the distract instruction given to patient. The consumer health research, they already demonstrate that when you adding some illustration or picture into distract instruction can help improve patient recall and satisfaction. That makes sense because sometimes a picture's worth 1,000 words. Sometimes some concept is difficult to communicate. You just look at the picture and you understand what it is. So it's raised another issue is how to realize this idea in the busy clinical environment. So physician and nurse time is too rare and expensive to be used for compiling image for patient. So we propose a solution to build a text-to-picture translation system that is used to illustrate a pictograph. So I enjoyed this, work with this product for 2 years. When I first started this product, nothing has been built. We have a set of instruction, a nurse, a cognitive scientist, and so the point is we have a more evaluator than a software engineer. So I have to build the system from scratch. So I feel very exciting that I can participate in the full circle of the software development circle. So I built the glyph system. The glyph system can translate text into pictures. This is some example. The actual implementation is quite complex. But I just say this, the basic idea is to map patient instruction into several distract concepts. And we build a rule-based system that map the concept pattern into pictures. How about the evaluation? In an early evaluation, we used the system to illustrate 49 patient instruction, and we use 3 raters to raise the quality of the pictures. A nurse, a graphic designer, and a software engineer. We use 3 scale, whether the picture is correctly represented, not represented, or wrong or partially represented. The results show that 66 of the pictures are correctly represented, with the integrated agreement 73.1%. This is a new created software, so this is a promising result for future enhancement. In an independent recall study, we recruit 84 participants from a convenience sample. So each person will review 5 illustrated instruction and 5 non-illustrated instruction, and we measure recall. So the results show that the one with the pictures enhance recall 5%. This is a significant improvement. So with glyph system, I was able to wrap up as a paper and submit to EMEA 2012 at Chicago. So this is my first conference papers. At the same time, I work on an information retrieval project, and I have a poster at the text engineering conference. So to conclude my first 2 years, this is a more enjoyable, relaxing time. And for my PhD, I have not feel the pressure of the graduate school yet because I have no pressure for graduation yet, very early in my career. I found that publishing paper is the way that you can attach your name into the software you develop. As a software engineer, you have a bold advantage and disadvantage to pursue BMI path. The good thing is you are good at programming, so you can develop and prototype the system very quickly, implement your idea very quickly. But the downside is you have a weak domains of knowledge, so you are restricted to some type of research, a more technology enhancement type of research. So in year 3, I'm working on the rule-based system, popular so-called regular expression. So this is a syntax commonly used in information extraction system. For example, using these patterns, regular expression, you can match on the email pattern in the document. At present state, regular expression are created manually, which is very dependent on the skill and experience of developers. So a question come up, can we learn those regular expression automatically? The point is, there are many ways to do regular expression learning. We present one way and we submit as a paper to JMIA. It got accepted. So the basic idea is to apply the second alignment algorithm. Second alignment algorithm is very popular algorithm used in bioinformatics. We use that algorithm to align DNA, RNA, gene, and protein to find similarity between those sequences. So I take that idea and apply it into natural language processing. I align several sample of text snippets to find the similarity and difference between those snippets. From those, we build a regular expression candidate. Those candidates we evaluate against the training sets. From that, we select a subset of optimal regular expression. So this is my first journal papers. From this project, I learned some lesson about publishing paper in a good journal. I gained some lesson, for example, in order to get in a good journal, your methods need to be novel. Your evaluation is rigorous, leave very few space for criticism. And when you get back the comment from the reviewer, you need to address it very seriously. When you get major revision, it means that you had to make significant change on the next revision. That is something that I learned from this project. So by the end of year 3, I already got a conference paper, a journal papers. More than that, I developed the skill to do independent research. I think this is time for to test whether I can create a new research project, to either whether I should show academia path or industry path. So in academia, you need to do independent research to create new projects. So I explored several ideas with Guilherme and John, and finally I know what to do with my thesis. In year 4, I'm not here in Utah, so I work in Chicago for 1 year internship. SIT had a grant in Chicago, Northwestern University that was similar to what I want to try to accomplish. And thank you very much for his grant that I can use all of the grant funding for my dissertation research. My lifestyle has changed a lot since I work in Chicago, both positive and negative ways. The thing I really like about the city is they are very efficient public transportation. You can almost go anywhere in Chicago without a car. So I very regret that I bring my car to Chicago, but leave it there for the whole year, I don't use it. The second thing is, this time I'm more concentrating on doing research. Although Chicago had many fun places to go, but I'm very sorry I don't have time to go there. This is my big mistake. So what I try to do in my PhD research is to enhance systematic review development. You can call it systematic reviews. So what is systematic reviews? The definition of Institute of Medicine is a scientific method to identify, select, assess, and summarize the findings of similar but separate study. It may include a quantitative synthesis or meta-analysis depending on the available of the data. So in a short word, systematic review is a summary of all relevant study to your research question. So why we had to do systematic reviews? Healthcare practitioner had to do systematic review, had to read some kind of systematic review to certify information need, to save time from reading primary literatures. Researcher can do systematic review to identify the research gap and to refine their hypothesis. Healthcare administrator need to do systematic review to generate, to making decision and policies to promote the practice of evidence-based medicines. So who conducts systematic reviews? It can be people from medical society. So medical society conduct systematic review to create practice guideline, which guide people on the field the current best practice given the current knowledge of medical knowledge. So in my research, I use clinical practice guideline from American College of Cardiology Foundation and American Heart Association. We attempt to fasten the development of the practice guidelines. So who are doing systematic reviews? It can be the professional systematic review development organization. So when I work, Cochrane Collaboration is one of the largest systematic review development organization. So when I work in Chicago, I have a chance to interact with one of the Cochrane group, the Cochrane Heart Group, one of the major group in Cochrane Collaboration. So I interact with the people there, and I found they recruit volunteer like medical student or physician in their systematic review project. But they're also the paid full-time members that work for systematic reviews. Some people consider systematic review is a permanent career. That's something they can do for life. And of course, individual researcher can do systematic review to find research gap and to refine their hypothesis. So motivation. What is the problem of the development and updating systematic reviews? So development and updating systematic review are costly, slow, and unable to keep up with publishing rate of biomedical literatures. It takes 2 to 6 years for a primary study to be included in systematic review. 23% of systematic review has not updated with new evidence in 2 years. It takes 1 to 1.5 years to develop a new cardiology guidelines. And average cost for guideline development in US 2003 is $200,000 per guidelines. So my thesis goal is to enhance the systematic review development, focusing on 2 steps, literature search and data extraction. So basic systematic review development includes several steps. First of all, you need to formulate the research question. Then you perform literature search. You perform screening to determine a subset of eligible study. And you perform data extraction for quantitative analysis. And finally, you summarize the result and disseminate in terms of publication. In this research, I only focus on two steps, that is literature search and data extraction, because though tedious and time-consuming and error-prone process in the whole systematic review development process. It also have a lot of chance for technology enhancement. So I construct M1 to enhance literature search. For M2, for data extraction, I break it down into two problems. One is try to extract from PDF reports, and the second is to use text summarization techniques to enhance systematic review developments. So I put all of the work under a central theme, that is to apply a computer-aided solution to enhance systematic review developments. So M1 literature search. This is the paper that I submit for John Morgan Award. I think I be here because of those papers. So the objective is to enhance the comprehensiveness and ranking of the biomedical search engine for clinical guideline topics. So in literature search, what you concern the most is the comprehensiveness of your search or recall of your search, because you don't want to miss any important eligible studies. The second thing is ranking is also important. A good way of ranking will increase the ratio of finding relevant study with reduced screening efforts. So our goal is to enhance the comprehensiveness and ranking. So our solution is to build a PubMed extension optimized to retrieve citation for clinical guideline topics. So PubMed is a very popular search engine for MedLife database. MedLife database is a very large biomedical literature database. It covers broad topics from medicines, pharmacies, nursing, and healthcare technologies. So an issue here is since it was designed to be general purpose, it's not optimal for domain-specific queries. For in context of guideline development, we are interested in clinical research for particular condition. So this is the proposed workflows. The user may be a librarian or any researcher submit query to our system. The system will automatically expand the queries according to our knowledge base. Then our system will query PubMed for a set of relevant studies. So when it comes back, it comes with the PubMed ranking. So we apply our study ranking to re-rank for a better ranking mechanism. After that, we pass the result into manual screening for the next step. For evaluation, we develop gold standards, include citation in development of cardiology guidelines. From the guideline, we extract on the recommendation and on the citation supporting those guidelines to build the gold standards. To know how well our system performs, we use some of the comparator. First of all, we use PubMed query expansion. We use PubMed ranking by default, ranking by relevance. And we use machine learning classifiers optimized to retrieve clinical sound study developed by Kirigolu et al. In 2009. This classifier attempt to identify the high quality study that we use to compare with our ranking approach. So we test two hypotheses. The first one is query expansion algorithm retrieve a perfect set of citation for a larger number of guideline recommendations than PubMed expansion approach. The second one is the citation ranking approach had a better recall AK than machine learning classifier and the standard PubMed ranking mechanism. We also measure some other information retrieval metrics, for example, recall precision, average precision. The results show that query expansion support larger guideline recommendation than PubMed expansion. The increase was 27%, a significant improvement. We also see recall improvement and non-significant loss on precision. So in literature search for systematic review, recall is the primary outcome because you don't want to lose any study from your queries, but you can certify some of the precision for better recall. For citation ranking, so citation ranking approach outperform PubMed ranking by default. We achieve an improvement of 21%, a significant improvement. We improve over PubMed relevant ranking. So PubMed relevant ranking do a better job than default rankings. So we have a smaller effect size, but it's still a significant improvement. For the machine learning classifiers, so Caligula developed very good classifiers used for rankings. It outperformed on the PubMed ranking approach, but my method is still doing better than Caligula approach with 4.2% with significant improvement. I don't go into detail how I do the query expansion and ranking, so I reserve for my dissertation. We don't have much time for this. So with that work, I were able to publish a paper in GBI about that work. This paper means several things. For my thesis, it back up with quality, the build a trust from the committee that I'm doing the quality works. For me, it demonstrates that I can do independent research. I can create a new project. So it builds my confidence to pursue a path in academia. It also enhances my research profiles and have a new idea for the future projects. So for M2, I'm working on enhanced PDF extraction. Motivation is that portable document format or PDF file is a common format to disseminate the research finding. So many journals don't allow you to view the content in the HTML format, but almost all of them you can download a PDF file. It's like a standard for disseminating the research finding. PDF reports are also primary source for data extraction in systematic reviews. When I was in Chicago, I have a chance to interview some of those developers. So they say PDF reports are primary source for data extraction, primarily because sometimes this is the only choice they have. They don't have others other sort of extraction. And this is also a convenient format, allow them to working offline. They don't need internet to do the extraction. So most of NLP study so far attempt to extract from the convenient HTML formats. So this is, I consider a research gap that I try to address in M2. So why PDF extraction is challenging? As you can see, in a PDF file, they contain many things. It can be semi-structured data, like table or figures. It can be publication metadata, like authors, journal information, or reference. Or it can be the human written summary, like abstract or title. Or it can be the primary content of the documents. The semi-structures, the publication metadata usually is not relevant to the extraction goal, but it can add some noise to the NLP system. Semi-structures may contain the relevant information. The extraction strategy is different from the narrative text. You cannot apply the traditional NLP approach on the semi-structured text. It usually needs a different type of approach. So my goal of M2 is to categorize text, extract from PDF document to high-level document structures, to title, abstract, body text, semi-structured metadata, and evaluate the impact of text classification on information extraction. The methods, so we propose as a method for automate text classification using the multi-passive algorithm. I don't go into the detail, but the idea is rather than you use a single pass model going to the document and classify like a machine learning classifier, you go to the document several times. Each time you try to target a certain part of the document. So the idea of the multi-pass model. So this is the workflows. You take a PDF files and you do PDF to text conversion using a tool called PDF box to do text extraction. And you perform the text classification to give some context to the text, high-level document context to the text before passing to the information extraction system. The IE system can decide to use those context in different way, but this is the primary contribution of the M2. To build the gold standards, we use publication report used in development of Cochrane reviews. We taking random sets of Cochrane review, we extract on the primary study, and we archive those PDF reports. So this is a bottom-up approach. Rather than we select a convenient sample, we start with the data come from the real-world systematic reviews. Comparator, we compare with machine learning classifiers, which I use the support vector machine algorithm. So how to measure the impact on the information extraction system? So I designed this experiment including 2 branches. The first branch is you to perform the text extraction and you pass into an information extraction system. Over here I use an outcome extraction system that developed for M3, but I take in here for measure the impact of the classification. On the second branch, I also extract text from PDF. I perform classification, and after that I filter on the publication metadata and semi-structured text before passing to the information extraction system. I test 2 hypotheses here. In classification of PDF text, the rule-based multi-passive approach is more effective than the machine learning approach. The second is in full text extraction, classifying and filtering semi-structured and publication metadata improve performance of information extraction. So in our sample size of 48 includes 36% don't have the content of available in HTML formats. So that further confirms that you need to do extraction from PDF file. Otherwise, this is a huge gap for data extraction. 84% don't publish structured results in clinicaltrial.gov. So many of the publications don't have a structured data. This is a huge change for NLP that go in and extract those structured data. For hypothesis 1, the multi-passive algorithm improve accuracies close to 12% over the machine learning approach. There is significant improvement. And classifying and filtering semi-structured data and publication metadata improve F measure 4.3%. And significant difference. It's more significant than that. It's reduced number of sentences by 46% without losing performance loss. So it enhances the efficiencies of the NLP system. So you get to M3. Motivation is that extracting from original study report is a standard requirement in systematic reviews. Full text extraction is the time-consuming and subject to human errors. So it's close to 58%. Cochrane review had data extraction error. 63% had error for at least 1 or 2 of the trials. So this is an example of data extraction template that conducted by systematic review developers. So our goal is to apply an NLP solution. There are two ways. NLP solution can generate the extracting template automatically. So this solution is, there are several problems with this solution, because when an NLP system suggesting an extraction template, it's gonna be never perfect. You're not sure whether the suggestion value is right or wrong, where it came from. So as a result, you have to review the whole paper again to validate your findings. So if you're doing that, you don't really need an NLP system. The second solution is an NLP system generate a summary to add with manual extraction. So we suggest using NLP solution as an optional supporting tool rather than replacing tool for humans. We use NLP system to generate a summary that might contain relevant to the extraction goal. This is what we try to achieve. The system can suggest some relevant sentences for the data element you want to extract. And from that sentence, it will recommend some of the key phrases that you can be used for extraction template. So my objective is automatically summarize full text publication at sentence and fragment level to assist with manual extraction. My methods start from a PDF file. I go through the process, the text extraction, classification, and filtering. This is M2 pipeline. Then I went to normalization. I normalized on the numeric value to their from literal form to their numerical form. I normalized all of the acronym from their short form to their long form. Then I perform the sentence segmentation. The key part is the sentence rankings. So I build a machine learning classifier for ranking sentences. And I apply some of the NLP techniques for extract key phrase from the sentence. Again, I don't not go into detail of how I'm doing that. So if you come to my defense next week, you will know the detail. So the output of the system is the top relevant sentences and recommended key phrase. For evaluation, we use previous sets of PDF reports in M2, and we annotate it into sample size, group size, population, intervention, control, and outcome. So our goal is to generate a summary. So the best place to compare is to compare with the human written summary, which is the abstract and the title. My hypothesis is that the machine learning classifier to prioritize sentence in full text perform equally or better than manual title and abstract screening. So I select recon as the primary outcome. We don't want the reviewer to lose any information from text, so recon I select as the primary outcome. So at sentence level, the machine learning classifier achieve 91% recon and 58% precision. For the hypothesis, the results showing that the performance vary in different data elements. So we have a non-significant improvement on sample size. Both intervention and population achieve 100% recall. For outcome, we achieve the significant improvement. So that makes sense because not all the information are present in abstract. For the data extraction, you need to revise full text for all of the information. We observe the precision is significantly improved for all elements. I think it's also important because it means our approach introduce some redundancy that can be help you to validate and increase the confidence of the result. At fragment level, we show that ensemble approach combines several NLP methods outperform individual approach. We achieve best F measure at 85.1%. So I am in the middle of the year 5. I was able to wrap up the work into my draft of dissertation, which could be defense next week. By the time I will be back in Utah, I really missing this place. I start looking for a job. My priority is academia and then industry. I still have 1 semester left to fight on this thesis and publish M2 and 3s. So in summary, if you want your kid to become a doctor, don't let them get too excited about computers. That happened to me, Guilherme, and I think few people in this room have a similar experience. As an international student, you need more time and training effort than the others. So I first joined the program, I see the barrier everywhere. So by the time I increase my language a little bit, but still have a lot of gap, lots of things for improvement. If you are in the similar situation, so you need to be patient and try to work harder. It's doable to finish your PhD in 2 years, only if you has been fully trained to perform an independent research. In a PhD, you need a publication to back up the quality of your work. If you have a publication, it's easier to convince the committee that you are doing the quality works. There are plenty of ideas in which computer technology can be applied to enhance traditional and clinical research workflows. Okay, thank you for your attention. By the way, I did some reading about Dr. John Morgan. He also had some engineering background before joining BMI. He started at faculties at BMI, academic professor before going to industry for his own business. And thanks for his successful business that we had the John Morgan Awards today. Thank you very much. So as the research, we build, we test hypothesis and we build prototype, demonstrate it's feasible. To be realized in the real task, you need more engineering efforts, investment, things like that. I believe my work can be enhanced into a software that can benefit many people. But again, it's money and more time. As long as I have those resources, I think that I can be a very good software to benefit systematic review developers.
Nice talk to you. We just finished and published a systematic review of nutrition informatics. And I'm always stunned in that review of the public that I see published. Reviewers will try to filter out irrelevant articles by looking at abstracts. Then when they actually get the full text and read them through this, then I fill out like 90% of what they pulled out. So the abstract clearly is not informative enough. Do you think your tool, because it is pulling out more salient and ranking sentences and fragments, might make that initial screen even more efficient so you're not wasting so much time reading articles that maybe you shouldn't have read because it's not that
Yeah. What you're saying is fit to the research about the prioritizing workload in systematic reviews. So basically, people using machine learning classifier to prioritize citation. So this approach is unsupervised. Those studies really require some set of training data. Unmet proposed methods is generalized for, I think it's work well for clinical research study. But if you are nutrition, you may need some metric in your domain, how you rank a study higher than the others. So it depends on your knowledge base of your domains.